All right, these are the worked out problems for 11.2. There's a lot of problems, so I tend to do them quickly. You can pause and come back if you need to look at things again. So we're breaking things into components. So this is 2 comma 3. All right, so it hits the point 2 comma 3. It is the vector 2 comma 3. Actually, just realized I made a mistake. The vector goes backwards. I didn't read the full question, so cross that out. So if it starts here and goes here, it's going left -2 and down -3. This vector down here starts at 1, 1, 2, 3. That's point P, and goes to 2, -1. That's point Q. Really should have drawn that in blue. So PQ, and again, I often see it with a little vector sign on top, is to the right 1, 1, 2, 3, down 4. All right, find the magnitude of the vector and the direction angle theta, blah, 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 0 to 360 degrees. This is -√2 comma √2. Draw it from the origin. All right, here is the angle. So the magnitude -√2 squared plus √2 squared equals square root of 2 plus 2 equals 2. And theta, I can just read this off. I know that's 135 degrees, but if you really need to, you can go 90 degrees plus arctan of √2 over √2. Notice I throw out the negative here because I'm just looking at it here. I'm trying to figure out this angle. It'd technically be 180 minus this, but I go with 90 and 45 on both sides. So you get 135 degrees. I would never do it this way. I would just look at it, know that it's a unit circle problem, and run with it from there. At this one, we will make our coordinate plane like this. It's -2. That's not 3 tick marks. It's down here somewhere. -2, -2 √3. So again, that's on the unit circle because the √3 thing, but I'm not going to get into that. So if we're going with theta, and I'm doing this opposite order this time, be 180 plus arctangent. And again, I'm going to throw out the negatives because I just care about the fact that this is a triangle. 2 √3, that's the opposite of this angle, over adjacent, which will give me 240 degrees. And then the magnitude square root of 4 plus 12 equals 4. Square root of 16 is 4. All right, so got an easy one here, which is nice. Right out here at -5 comma 0, so the vector is right there. So theta is 180 degrees. And the magnitude of -5 comma 0 is 5. Nice, get an easy one. Oh, cool, another easy one. So we go right up here. to 0, 4. Theta equals 90 degrees. And the magnitude. Notice I'm writing it different ways. I like showing different techniques. Equals 4. Like I said, I'm going fast. Need to rewind and pause by all means. Okay. Find the component. And yeah, find the component. All right, so 6 long, 270 degrees. So there it is, 270, and it goes down here to basically 0 and -6. So that means the vector is 0, -6. This one goes out here to 200 degrees, which is going to be in here somewhere. This is 13 long. So that's 180. So we can do it this way. X, they're both going to be negative. -13 cosine of 20 degrees, -12.216. Y, -13 sine of 20 degrees, -4.446. All right. 3√2 pi/4 radians. X is 3√2 cosine of 45 degrees equals 3. Y is 3√2 sine of 45 degrees, 3, 3, 3, which we probably could have done without all the math. I mean, it's on the unit circle. 3, 3√2, it's a 45, 45, 90, so on and so on. X, 2√3 cosine of 30, 2√3 times √3 over 2, also known as 3. Y, 2√3 sine of 30, √3. Comma √3. All righty. Onwards. U equals this, V equals that. What are we messing with? Well, -2 times V. So -2, -2, comma 5, 4, comma -10. Wants the magnitude. Equals square root of 116, or 2√29. All right, U minus V, which is 3, -2 minus -2, comma 5, 3 plus 2, 5, -2 minus 5, -7. Magnitude, √74. -2, 3, -2, plus 5, -2, comma 5, equals -16, comma 29. Sorry about that. Magnitude, root 1097. Yeah, you need a calculator. This is a classic. It's obviously a triple, and her magnitude should be 1, something like that. Oh no, it's not necessarily. We'll see. So yeah, it would be if u and v were simple vectors. They're not. -5/13 times 3, -2 plus 12/13 -2, 5 gets us this bizarre -3, 70/13. Sure, whatever you say. Magnitude, big math, off we go. I don't even know if that reduces or not, and don't really care all that much. All right, here comes our classic math problems, physics type problems. River flows due east and yada, 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 whatever. So east means that the river is 2, 0. Canoeist is going across the river, northwest. All right, so this was the river, this is the paddler. So canoe is going to be left -4√2/2, 4√2/2, because that's just 4 times cosine where it is and 4 times sine, which is -2√2, 2√2. Okay, what's the true direction? We got to add up those vectors. So we get 2, 0 plus -2√2, 2√2 gives us 2 minus 2√2, 2√2. This is going to be up in this general direction, so you're still paddling that way, but it's pulling you this way, so the arrow is going to be a little more up here. So theta equals, I'll do the angle here, so 180 minus arctangent, 2√2, the y, over 2 minus 2√2. And I'm going to put an absolute value on here because I don't want the negative. The 180 minus accounts for the fact that it's over here negative. So we get 106.325 degrees. And if I blast out the magnitude, 2.947 miles per hour. Magnitude, of course, is just this squared plus this squared, square root. (16 through 18), a particle travels, blah, 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 find velocity and all that. Okay. V of t equals 2 cosine of 2t, comma, -2 sine of t. Acceleration, -4, sine of 2t, -2 cosine of t. V of t equals -6 cosine. Whatever, I try and do things quickly. 8 cosine of 4t. And the acceleration is negative 18 cosine 3t, negative 32 sine 4t. Not much to say about that. And down here, yes, to be difficult, v of t equals sine of t plus t cosine of t, comma, cosine of t minus t sine of t. Acceleration, cosine of t plus cosine of t plus negative t sine of t, comma, negative sine of t minus sine of t minus t cosine of t. Good practice. See if we remember our product rule. 2 cosine of t minus t sine of t, negative 2 sine of t minus t cosine of t. Math, baby. All right, velocity of a particle moving the plane is given along position. Find the position of target T3 and distance from travels. Okay. X of t, 2 pi. Yeah, so I'm integrating. 2 pi sine of 4 pi t over 4 pi plus c equals sine of 4 pi over t, sine of 4 pi t over 2 plus 7. Initial position, plug in 0 pi, left with 7, makes sense. Y of t equals, integrate, negative 4 pi cosine 2 pi t over 2 pi plus some c. Plug in 0, and things are a little bit different here. So if we plug in 0, we get, let me finish this first. 2 pi cancel, I get negative 2 cosine of 2 pi t. All right, plug in 0, and I get negative 2. Negative 2 plus this c equals 2. Negative 2 plus 4. All right, if you need to write this out, I don't blame you. It's tricky. R of t equals, at time t equals 3. Oh, well, we're supposed to get 7 too. So plug in 0 and we get 0 plus 2, comma, negative 2 plus 4, 7, comma 2. And let's see if I'm answering these right. Find the position of the particle at time t equals 3. And the distance of the particle travels from 0 to 3. Well, that's 2 different answers now, isn't it? R of 3. Wow, my answer key is wrong and not done. So now I got some work to do. Boy, people force me to do my job. It's very upsetting. Anyway, that was me checking, making sure things are copacetic at time 0. Really should say 0. And when I plug in 3, all right, sine of 12 pi, 0, 7. All right, cosine of 6 pi. Let's see, at 2 pi, 4 pi, it's 1, plus 4 is 5. So that's the position. And then the distance traveled, 0 to 3. Not writing all this out. All right, I'll write all of it out. 2 pi. I put the y first? Doesn't seem right. That's right, it's the derivative. Never mind, I put the x first. I would have put r of t in here. I would have been wrong. I have to put the derivative, the velocity in here. 2 pi cosine, good thing I wrote this out. 4 pi of t, that was really smart of me, plus 4 pi sine of 2 pi t squared dt equals, wow, running out of space. That's scary for a single problem. 28.523. Any position? No, no units. Wow. That's yeah. All right. X of t equals e of t minus t squared over 2. The original position is 1, so plus c. Plug in 1, I get e minus 1/2 plus c should equal 1. Plug in 0. Plug in 0, I get 1 plus c equals 1. C equals 0. So we just get e to the t minus t squared over 2. Y of t equals e of t plus, having trouble seeing this tiny font, plus c. All right. C is going to be 1, so plug in 0, gone. No c again, which is nice. E of t plus t squared over 2. All right, r of t equals e of t minus t squared over 2, comma, e of t plus t squared over 2. R of 3 equals e of to the third minus 9/2, e to the third plus 9/2. Told you I do this all the time. Try and make sure those are blocky. And then L equals integral 0 to 3. Sorry, I'm having a little trouble here. I think I might have screwed up over here. R of 3. Yeah, I don't see that being right. Plugging in 3 over here. -2 times 1 is -2 plus 4 is 2. So my notes were right. I just forgot to write it in right. So R of 3 is also 7, 2. Apologies. All right, length, yada, yada, square root. Remember, original ones, e to the t minus t squared plus e to the t plus t squared dt equals 20.627. Math, damn it. That's hard. Particle moves with position vector, find the velocity and speed. V of t equals pi secant pi t tangent pi t pi secant squared pi t v of 1/4 equals root 2 pi 2 pi. Speed, I don't know if I covered this in class. Square root of these, root 2 pi squared plus 2 pi squared equals root 6 pi squared equals root 6 pi. This particle is moving along a hyperbola. Yeah, I think so. Eliminate parameter. That's hard. X equals secant of t. Let's square it. Oh, pi of t, my bad. X squared equal, why are we squaring it? I don't know. See if it works. You can square it of pi t. Y equals tangent pi t. Let's square that. Y squared equals tangent squared pi t. X squared minus y squared equals secant squared pi t minus tangent squared pi t, which I happen to know is 1. X squared minus y squared equals 1. You say, why didn't you just tell me in the first place, oops, that it was a hyperbola? Well, it matters. These set where you start when t equals 0, and they set the direction you're going. Yes, we've talked about this. Select, oh, there it is. Sketch the path of the particle. All right, well, we got this and this. It goes over 1. Plug in 0 to your position. Secant is 1 over is 1. That's x. Plug in 1. Y tangent is 0, so it starts here. And then just plug in some values, it starts going up here. So you'd say, well, it's not a hyperbola. Well, yeah, it depends on where you go. So 0 to 1/2, plug in 1/2, see where you get, whatever, I guess it ends about here. And that is our starting point. That's it. Wow, that's it. Thank goodness. There's a lot of problems. I'm tired of doing them. Anyway, have fun.